morning, so I think there's still a few people sleeping in. Welcome to BCF SIGIST, first of all. So I'm going to talk a little bit for the next few minutes about what BCS is and what SIGIST is, because I know lots of people aren't members of BCS, don't know what SIGIST is. One question first, though. Has anyone been to a face-to-face SIGIST event before? 3 people, and me, I guess. So SIGIST used to run annual conferences in London that were really, really good a number of years ago. The committee changed just before the pandemic, and since the pandemic, we've mostly been running webinars for obvious reasons. We ran lots and lots of webinars, and we had really good topics, really good speakers throughout the pandemic, and really kept SIGIST alive. We've now started to do face-to-face events again. This might be annual. We're very much testing a new format here. We're very lucky in that BCS has these futuristic facilities. The coffee machine is particularly futuristic and difficult to work. So we're able to do hybrid. So we've got another room just there where we have the online track, semi-online track. So you'll see there's 2 lists of speakers today. This is the face-to-face room. If there's a talk you want to see that's online, you can just go through to that room. If everybody goes through to that room when I start my talk about testing standards, I'm entirely surprised. What else? Health and safety. There are 2 fire exits. There's the way you probably came in through there, and there's a push door thingy by the atrium. There's a fire. It's leave the belongings as quickly as possible. Okay. So, British Computer Society, if you're not familiar with it, there's a whole load of branding stuff, but I think this probably describes what BCS does in pretty good detail. For individuals, obviously BCS sells membership. It is not for profit though. It doesn't make money, it reinvests a lot of money into the community, which is why we're able to put on events like this at such a low cost. BCS is involved in qualifications, both working with universities and professional qualifications, and even apprenticeships. If you're a testing apprentice, your endpoint assessment is done by BCS. Organisations can also join, lots of big corporates and universities. Training I've kind of talked about. And the other aspect is government. BCS briefings do end up in the Cabinet Office and going into consultations. We have quite a big policy team. They've got a big policy presence, I think, not necessarily a big team. So things like testing COVID apps during the pandemic, things like that, we as SIGIST get asked for our opinions to feed into Whiteboard. So encourage everyone to join BCS, but you don't have to. All our events are open to non-members as well as members. In terms of BCS SIGIST, we agreed a bit of a manifesto last year in terms of what we want to do. We want to be open. We want to be aimed at the software community and the whole of society. We don't have people paying to talk at these events. These are all real experts who want to talk about a topic that really interests them. We also like to make it open to people outside of London, which is one of the reasons that we're trying this hybrid format today, to make sure that we can make it accessible to people who live up north or down south. And in fact, I'm based abroad. We have members who are based in other countries as well. We want it to be inspiring. We want to inspire people who are doing software testing. We want to be inclusive. We want to make software testing reflective of the community. We want to support professionals through events like this where they can learn about emerging topics. And it must be trend setting, raising the professional bar, and that might be working with government. Yesterday, I had a meeting in, I think, this very room with the National Preparedness Commission, who are wondering whether, so the National Preparedness Commission was established after COVID because we weren't prepared. So now they're looking at other things we might need to be prepared for. One of the things they've identified is software, in terms of resilience, in terms of supply chain, in terms of complexity. And they're analysing whether it should be added to the Cabinet Office's National Risk Register. Not software testing, but software quality and software resilience. So they were interested in what industry professionals think. So that's BCS SIGIST. So I've got a couple more minutes. The speakers today, we will have, I think they're running at exactly the same times in both rooms. We'll have various breaks throughout the day, coffee, picking work machine. And then we have lunch, and then I think there are drinks at the end of the day as well for networking. So full day of stuff going on. We do encourage you to post on social media. to promote us, really. I don't know what the social media of choice is this week. Would have said Twitter a couple of weeks ago. I'm currently learning about Mastodon. Maybe you're on Facebook, I don't know. But yeah, if you can give us some social media love during the event, post pictures of any speakers that you think are doing great work, that'd be great. Also, the event is being recorded. There's a camera up there. If you're a fugitive or concealing your identity or something like that, you might want to sit at the back here. If you have any objections to potentially being recorded, please let either myself know or Mike. Mike, can you raise your hand? There we go. Last but not least, just thanks to Mike, who's put together the event today, really in the detail, working with all the speakers, putting together the schedules, dealing with all the promotion. Thanks to Jonathan, who's next door, opening the remote stream. He's going to be our first keynote speaker in here. Jonathan helped us secure support from our 3 sponsors, Test House, Eggplant, and Atos. And that helps us keep the cost really low for everyone. I think that's it. Is there anything else, Mike, I've missed?
No, I think you've got everything there. That's good.
Good.
Thank you.
Well, that was quicker than I anticipated. Let me see if we're ready for our keynote.
Is there a stream for this room, or is it just the other one?
There isn't a stream for this room.
I think there is a stream,
but it's not live, right?
It's not live. No.
It's not live.
But it will be available on demand.
Yeah.
Okay.
So all the talks will be posted on YouTube later. Okay, so over to our first keynote. So many of you may know Jonathan Wright. He is one of the organisers of the event, one of the sponsors, and our keynote speaker. He's Chief Technology Evangelist at Eggplant, and a prolific speaker on emerging technologies and software testing.
With that said, I'm going to tab on to my slide deck just to show how good technology is for a second. Thank you, Adam. That's one up. So, if you want to go and see, there's another track. Just checking for Mike, what's the track that's going on at the same time?
Keynote speech in the other room, well, live from Germany, is Andrea Jensen's talking about ensemble testing.
Wonderful. So yeah, I won't be offended, don't worry if you nip across there. If not, this is going to be about 45 minutes, and then I'll be moving on to the next speaker. So I'm actually doing my presentation from this year's Star West. So it'll give you a bit of a kind of an intro to, I'm going to talk about 2 things primarily. One, Metaverse, which I guess most of people will be kind of going maybe a bit too soon. I was actually in Barcelona for Gartner last week, where I caught up with Adam, where he normally lives. He's flown in for this event. And of course, it's the highest item on the Gartner hype curve, 7-year runway. And I know the pain of the 7-year runway, because literally I'm leaving this event to go back to our offices in London to sort out some stuff that we're doing with Microsoft and mixed reality. So, part of it is this is practitioners' experience of what we're doing with Microsoft, Meta, and a few of the other people developing XR experiences, mixed reality experiences. I'm also going to be talking about digital twins, and I'm going to this is the topic which we covered off as part of the BCS book, which was released in March. So that was with Adam. Who else was on the list?
Rex Black, Jeremiah Rossler, you.
Me. There was a lot of other really good speakers on there, but so that was artificial intelligence and software testing. It kind of came out the back of the ISO 29119 Part 11 for AI in software testing, which you sit on the ISO committee as well for Part 8, which is model-based testing, and however many more parts there is, lots of them. So I thought, okay, I'm going to talk about Metaverse, digital twins. I'm going to add a bit about quantum computing and what we're doing with Azure Quantum, which is Q#, and also cyber robotics, which does feel very much Skynet-y at this point in time. So, of course, I think there was an introduction at the start around my role. I kind of sit as the Chief Technology Evangelist for Keysight, which is, in essence, for those who are not familiar with Keysight is the old Hewlett-Packard. So if you think about the garage back in 1938, and the first ever test equipment that was sold to Disney, that technology is now Keysight as the quickest version. So here's me actually doing my Star West conversation whilst wearing a HoloLens, which was quite annoying based on the fact that I had a whole stack of things in my way while I was going on the stage. But yeah, so looking back at the original 1939 build and test kind of principles that Dave and Bill put together in the garage, which was the birth of Silicon Valley. And then to the right-hand side, just a few miles away from where I live at the moment, is Bletchley Park, which, has anyone been to Bletchley Park? Yeah. 1, 2, great. And so that actually still has, which I checked a few weeks ago, the original papers Alan Turing wrote around the singularity and artificial intelligence back in 1950. So when we're talking about AI, this isn't really new. I was actually chatting with Tarek King the other day from Test.ai, he's now moved on. And he's been presenting, I think it was a cast last week, introductions and trying some of the base fundamentals of the difference between machine learning and artificial intelligence, because of course the word is massively overused. But I'm going to leave the closing keynote for Adam to talk about regulatory compliance of AI algorithms.
I'm testing you.
And testing them. So if you're not asleep by the end of mine, you will be by 5 o'clock today. We're going through all the top topics. So going back to the start of kind of our heritage, I suppose, we've kind of come a long way, and they acquired a company called Eggplant, which was a 2008 based company out of London. And my afternoon with Gareth, who's now the CEO, is talking about how we actually going to engage in testing the metaverse with computer vision and some really cool tech, which I'm going to be showing you later on. Just in case you're interested, that's the original first piece of test equipment back in 1938. Humza knows it because he's used it, haven't you, Humza? Yeah. Which actually is part of because back in 1939, they didn't make the metalsmith, so this is actually a toaster, which they actually built the first ever test device in. Very interesting piece of fact, but it was done for Fantasia, and Fantasia was the first stereo sound for Disney. So that was done with that piece of testing equipment. The other thing which is quite interesting is where our offices are, just a few miles away from Ada Lovelace, and I'm going to be talking about Ada, Project Ada today. But I guess everyone knows who Ada Lovelace is. She was the first computer programmer. She actually lived in this very subtle, small place just a few miles away from Leatherhead, which is where our R&D offices are based. So bit of history. Now I'm going to kind of talk about kind of some of this emerging technology and why we're talking about things like quantum. So, one of the things that we've been doing at the moment is around 6G testing. So everyone's got hopefully 5G at this point in time, even though I can't get any signal. But we tested the first 6G waveform, which is a new standard which is coming through. And we actually Keysight did the first transfer on a 6 gigahertz test rig, should we say. So we're doing 6G, and I'm going to show you some of the 6G stuff that we're doing at the moment. We're also doing autonomous vehicles. So back in January, I was at the kickoff in Vegas for CES, and we actually launched an autonomous radar emulator, which is a testing rig for testing Car2X and as well as radar systems, so autonomous driving vehicles. Again, I'll show a demonstration of that later on. Just make sure people are pinging me for some reason. Anyway, so one of the things I'm going to give you a link. If you do go to keysight.com, you can check out that we did a conference about 2 or 3 weeks ago, and it was over 3 days, 6G, quantum computing, digital twins and artificial intelligence, and automotive. I did a session, panel discussion with Dr. Poppy Crum from Stanford University, who's a neuroscientist, and we talked about how we apply digital twins, and I'm going to be showing that first off before we go into the exciting metaverse stuff. But yeah, it's completely free, all thought leaders, and it's 100 minutes, so it's not going to take loads of time to watch through. And it doesn't have any product placement whatsoever. It's purely just thought leaders in the space, which helps, obviously, as we're at the BCS back at the good old days, not at the gynecology location, which was a bit more of a commute. So we know things are more complex. How do we deal with this kind of complexity? And ironically, poor Adam has flown back today to deal with a large UK government entity, which has hundreds of these systems that they're looking to automate, and you're integrating your platform, which has got to discover all of this and do predictive analytics again. So good luck with that. That's going to be a great bit of fun this week. So during lockdown and me looking slightly more bearded than I am today, I put a book out about accelerating software quality, and a few of us, including Adam, we were working with MIT for the contact tracing, and part of the story that's in that book is about using digital twins to simulate, which we presented actually at the last BCS, historic routes through London, and then actually testing both the original GPX or GPS, as well as the games, Google and Apple exposure notification. So I'm going to go through the use cases in this book first. So what is a digital twin? Now, the best example, I'm hoping there's not sound for this, is I think most of you have probably seen this before, which is a digital twin of Bruce Willis. So recently there was an advertisement done by these deepfake guys, who was a deep fake, where they overlaid onto a standard actor Bruce Willis's face. And part of the question was from the Actors Guild is, you know, should you create a digital twin of yourself? So then if, for instance, something did happen to Bruce Willis, he can still make Die Hard 3, 40, 41, 42. So that's a kind of a digital twin of Bruce Willis. So what does that mean when we talk about software and software testing? So systems are incredibly complex, and we kind of alluded to the ISO 29119 Part 8 for model-based testing. Again, model-based testing isn't anything new. It dates back maybe 10, 15 years. There's a great book by the ISTQB on model-based testing, and also the new standard, but also people like Dick Bender, who've done their life's work on things like RBT, have talked a lot about how you apply model-based testing. So I'm going to take model-based testing as kind of the foundational understanding and apply that to software systems. So one of the things I've talked about for quite a long time, and it's not just because of my surname, is about how this beat kind of pushed towards shift left. And kind of my focus has always been on shifting left, but also shifting right. So how do we learn from the systems that we're running today and actually allow us to create a digital twin of a system that already exists, which is the example that I'm actually going to give today. And I actually did this at Swiss Testing Days a few months ago live, and let everyone actually use the system and then show them what interactions they did with the system over the 10, 15 minutes keynote. So I'm not going to do that today, but you know, it gives you a bit of an idea. Ask Hamza, he'll give you a demo of how it all works. But in essence, what we do is we look at all those interactions that are happening, and in essence, they're unique journeys that are flows through the system. And then what we do is we map and model those journeys over into a digital twin. And that digital twin has every single interaction and path that's gone through the system. So in essence, it goes from observing test observability of a system, which could be pre-prod, it could be a UAT, BAT, it could even run your current automation or manual testing, exploratory, whatever else it is. You can then capture it and then create a model. So it's like we refer to it as hyper-baselining of multidimensional transactional data, but in essence, it's just pulling the current state and understanding the landscape. So how do we do this? Well, unfortunately, I keep on coming up with stupid names of things. Ada Lovelace, a bit of a nod to her, like everyone's talking at the moment. And obviously everyone loves the flux capacitor thing, Back to the Future. But we look at and we observe the system at three levels. We look at it from a network layer. So we're looking at the underlying PCAP traffic that goes between each one of the systems. We observe both the API, so things like OpenTelemetry. So observing OpenTelemetry from maybe an existing APM or some log analytics, or by spidering, transposing, using security tools to discover the system. And then, of course, we can do things like sharing bots to go through and auto-discover through the UI, but not as stable, unfortunately. So once we've got this, this kind of three-dimensional data, we then look at creating that model. So what you see on the right-hand side, which is keysite.com, is we have a file that launches there, which is actually sending out telemetry data. So that could easily be replaced by, if you're using App Dynamics, Dynatrace, New Relic, Splunk, it doesn't really matter. But that information comes across, and it's not just for web pages. So it could be systems, APIs, it could be underlining transactions that are going through some kind of MQ system. It's, you know, it's kind of agnostic. But once we've got that information, we've got this horrible kind of spider diagram, which is it's not very useful. And the problem is when we think about things like model-based testing, we design a model based on maybe the logical structure of the actual application, or maybe we do it based on behaviors through the system that we're expecting. We don't particularly kind of model it just every possible transaction. So we take this and we look at how we create what we refer to as feature clustering, which is looking at certain components that are, you know, keep on recurring. So in this particular case, the order confirmation flow is quite linear. We're able to identify that as a kind of a number of transactions that keep on happening as part of each user journey. Not on that screen, obviously. And then what we do is we also look at, you know, things that change. So in this case, there's a repeat transaction that's happening. Now that could be an order repeat where people keep on going around and adding more products, Black Friday, but it could be other things like search results, et cetera, et cetera. So in looking and acknowledging the behavior of the system, and once we understand that, we can directly correlate that to those individual transactions, which in essence become kind of a test case, should we say, or a test scenario. I don't know what terminology to use because of the ISO and different other standards. But once we've understood that and we've started modeling that out, such as repeat order, we're able then to actually kind of start splitting them up and actually creating a model that isn't just a gigantic spider diagram, but actually is something that's much easier to actually manage. So a logical, maybe it's broken down by the logical structure of the actual application, or these features are in a certain area, like checkout becomes a single flow. So again, taking standard model-based testing, taking the understanding and observed behavior. So in theory, you've gone from 0 tests written, automation written, to observing all of these systems interactions and then kind of having to sit and understand them. And then the next step is, once you've got this, you're able to then start creating more reusable components and then applying sophistication to it. So if you're, because really the human's got to be in the loop for this. So if you understand derivatives, then you have to apply that to the core logic, which is part of your script, which we normally do with any type of BDD, TDD, ATDD, or other type of methodology. In this particular case, you can see how we've gone from standard spider diagram to reusable components that are easier to maintain and understand by using this process of going through and feature clustering things and then trying to then, on top of that, abstract all the domain knowledge from subject matter experts like yourself. So again, feels incredibly complex, but you know, we're taking something from just observing behavior, and then we're creating and reproducing that exact same actions that happen. So I did it with Dynatrace as a bit of an example, because I was with Henrik and Andy, who are working on open telemetry for Dynatrace. But we actually observed a system for a period of time, which could be a regression pack being run, could be some automation scripts run in Selenium, it could be some Postman scripts, whatever. Observe it and then run back the exact same run. Now, what was interesting about that is when we repeated it and run those exact same transactions, we can then observe differences such as performance, degradation in the system functionality if something isn't there anymore. So we can go through and actually understand every single journey that goes through and how that has actually been retested. We can see the screenshots and maybe the request response pairs coming from API tests or something like that. And then we can actually look at it and go, well, we ran it on the 26th, fine, 27th. Now the response time's gone up. We can, keep on doing regression against that hyper baseline state. And as it evolves, as far as the application evolves, so does the digital twin model. New functionality appears, new functionalities then got to be interpreted and actually added to the model. So anyway, with that really simple explanation of model-based testing and digital twins, I'll now go on to the fun stuff that people are actually here for, or hopefully they were. So Metaverse. So this is the book and the other people who did write the book, just in case you want to do it. It's available on the BCS website. It's also, if you go to Eggplant Software or you ask one of us at the back, we're giving away free copies of this, which has helped our sales for this year, I suppose. So yeah, and if not, I've even got my my AI to read it to you if you can't be bothered to read, which is also one of the things that I suffer from. So moving into the metaverse. So we're playing digital twins, things like observing systems behaviors. You can probably expect that once you go into a metaverse kind of scenario or Web 3.0, decentralized internet kind of environment, how do you test these highly complex systems, which is my afternoon getting shouted at with my R&D team. So the way that we've been testing, and I'm going to show you today some of the stuff that we've been doing, is Keysight make pretty much these hardware testing. So we can do anything from network and protocol emulation. So I'm going to show you how we can actually manipulate beacon data that's coming in from your 4G, 5G cell tower. We can show you how we can actually take the network and create the protocol analyzer to actually then inject a particular packet loss or some type of digital twin of a network system. We've got the cyber physical systems of 6-directional robotic arms, which we can drop into these large environmental containers and then change things like the ambient temperature. We can add in things like recreating twilight. So if someone's using the mixed reality headset, trying to look at a battlefield as an example, they can see, can they still see the information augmented onto the GIS kind of landscape. So bringing all of this together allows us to test at each layer, not just the UI layer, but the physical layer and the protocol layer, and allows us to actually test things like the HoloLens, which is and a bit of an interesting use case. It's like the old slide. But like I said, we're taking these components to be able to create realisms of both the hardware level and all the 12 sensors that are on here, gyro and different near-field LiDAR kind of camera feeds. And we're able to take all that information and actually feed it into our digital twin and then be able to test, A, what the user looks like, but also look at things like the battery drain, look at the GPUs, look at the underlying processors that are going on, and also intercepts the signals. And then for you that you maybe not looked at kind of these kind of HoloLens technologies before, so this is a bit of a bad example of me trying to connect to the Wi-Fi whilst on the plane. And what you can see about this is when I dock the browser, obviously this lady wants to go and sit next to me, so I have to kind of get out, but this is going to stay in this one position. So I can move, and everything it understands the depth. It scans the entire landscape, and then it can actually understand where I can position items. Now, of course, automating a browser, well, we all did that many years ago with Selenium, but once you start understanding three-dimensional landscapes, so if you're thinking of a battlefield, they can see through a tank and through full 360, and we actually do it with fighter jets where it wasn't unfortunately Tom Cruise didn't have this technology in Top Gun 2, but you can actually look through the bottom of the fighter jet and actually see directly through. So we're testing these things at high speed, 120 frames per second, full 360 degrees, and then understanding like this little gecko. This gecko will run through and understand if there's a wall and drive through the wall, but disappear and come out of another wall. So it kind of understands the the environment that's around. And in this case, I was still waiting for the plane to come off, take off. So I actually went straight to the air traffic control and I was able to see the planes. Now, of course, I'm no good at navigating flights, so it made no difference to me, but just kind of shows you how you can pretty much start interacting with these kind of environments whilst in a very strange environment like a plane. But anyway, to give you a bit of idea of what mixed reality looks like, I have to use the great example of a dog. But as you can see, the dog here has seen the chair and then decided to actually not render a dog there. So we're looking at things like being able to intercept the data, distort the image, actually add noise or interference onto the actual environment, change the cameras to feed in different types of three-dimensional models, six-directional models, to recreate these and actually test whether or not they're tethering, whether or not they're displayed correctly. So if you think of a battlefield with the enemy tanks and drones filling in where everybody is, that's near real-time information of being able to see through walls. Kind of gives you kind of superpowers, which is quite useful. But using computer vision, we need to understand what a dog looks like at multiple different angles to be able to actually recognize a dog in the multiverse in a very, very similar way. Google Computer Vision recognizes a dog on a beach with another dog. Part of it is we're having to train these systems to understand. But as you could probably expect, that is actually a wrapped image. It's not a two-dimensional image what's coming through. So it's actually made up of maybe 4 or 5 different cameras. So how do we test it? So here's a bit of an example, which is what I sent this morning, which is why this file is now 2.5 gig, not 2 gig. So, being able to set the 6-directional kind of gyro is fairly straightforward. However, your head doesn't work like this unless you're from the poltergeist, right? So part of it is we have to have things like hand physics, pose physics that we apply to say, how is someone looking at this? How do they interact with this? How do they gesture, interact with this environment? And again, how do we actually see it in this 3-dimensional space and then interact with it? So, you might say, well, being able to understand text, which is what it's looking for at the moment, using OCR engines, that's one point. But once we've got that reference, we've then got this, a bit like the quantum computing, 6-directional state. You've got to understand, okay, if I turn my head by the hue by 4%, and then where is that now going to be positioned on the screen? So then once we were able to actually understand that the positioning within this kind of, let's say, metaverse, but this model environment, then we're actually able to tell the controller to actually move and locate and interact with that, and then send a gesture, which could be click, or it could be, some other kind of command. So again, we're just using a very simple model to actually drive this, and it's a very simple example. But as we're actually doing this, we're also pulling out all the telemetry information. So that's my afternoon conversations, but that's things like the GPU, the underlying network stuff, every single one of the sensors. That's actually Gareth, but you can see that there's actually pass-through cameras, which you actually have to take those because both of those provide LiDAR for your depth perception. So that's kind of how we're testing it at the moment. That's an architectural diagram that I sent out yesterday, which is kind of gives you an idea of what it is. So these are actually the camera feeds. So you've got these depth cameras here, and then you've got the visible light coming from the different cameras, which it uses to create the model. And then the model then puts me into some kind of 3-dimensional structure. And then we test that via either emulators, remote handsets, or actual physical kind of lab environments. And then, I kind of, when I was talking to the Dynatrace guys, Andy at Star West, I said to him, are you going to come see my session on the HoloLens? He was like, we did the HoloLens like 4 years ago. And this is actually Dynatrace's HoloLens app, which is available on their marketplace. They've obviously got 2 people in the same room, but these people could be in different geolocation, Tokyo, somewhere else. They're able to actually look at, real-time data coming from the system, do what they refer to as pure path, but understand the exact transaction, what's going, and then collaborate on actually be able to interact with that data, pull out metrics, pull out feeds, and discuss maybe root cause analysis, pinpoint failure analysis. So, there is practical use cases of this already implemented. It isn't just a kind of a pipe dream, but of course it's overhyped in the sense of when people think about Metaverse, they think about Oculus and VR and Beat Saber maybe, not thinking about, well, what's the real, remote collaboration opportunities where people can go and look at the Cassandra database and look at the throughput and collaborate on, what the underlying issue could be. So to kind of give you an idea what kind of stuff that we're doing for the new HoloLens 2.0 and the Oculus Pro, which I'm going to show on the next screen, we're actually using OpenCV to recognize movements of your eye, and then we're replaying that just with a custom Raspberry Pi build that we've got to be able to reproduce that exact same eye movement. So, both Apple, when they released the Apple glasses in 2024, which has now been delayed to 2025 as of last week due to that 11,000 cuts. No, that's Meta, but same kind of thing. And also the Google glasses are both going to take Retina as for payments. So instead of doing your Apple Pay, they'll just look at your eye and then, authorize the payment. And then, of course, we're also using things like Connect to understand the body structure and skeletal structures, and then do things like be able to understand, which you can't really see, that the hand has been closed or it's open, or there's a gesture or pose that should be recognized by the system. So then once you've got this, you can actually then feed into something like, this is when you remember that you didn't tell it to auto start when you pasted it in this morning. Nearly for a full day. But this is the Oculus Pro at Barcelona Gartner last week, and you can probably see the avatar, my avatar over there, which is opening its eyes, it's smiling. And the idea behind that is to do this kind of new Windows mesh, which is in essence Teams, but within 3D spaces. I can dance or attempt to dance in VR. But also, to be able to understand if you're smiling, whether you're actually attentive to the actual meeting or you're just completely asleep. So you can see me closing my eyes and opening my eyes. It's recognizing gestures, recognizing emotions that are happening in that space. So definitely worth £1,500 if you want to buy one of those for some unknown use case. So now we've talked about a little bit about kind of the metaverse. I wanted to just tease with the last kind of 10 minutes before we go into some kind of Q&A, some of the other stuff. So I talked about the autonomous radar capability that we launched at CES. So that's what's under this beautiful back blanket, which looks like a spaceship kind of dashboard from the Enterprise. But what's interesting, which is why I was recording this, is actually our devices here are actually Car2X devices. So the scenario which you're going to see is it's running a simulator where someone's driving down the road. Now, of course, the radar emulator can see anything what's going on the road, like Tesla, which is a kind of a party trick. But what happens if there's a car that's behind a building going at high speed? You have no idea because you can't see that car. With Car2X and infrastructure to X, then you can literally start braking before that item comes straight out of the hidden behind behind the building. So we're using these technologies, which I apologize, I'm sure the guys at the back know what they are, but they call them bees. And then this radar emulator, which, I must admit, I kind of was slightly upset that I realized that there's actually just a plasma screen behind that, because of course radar isn't able to be able to see by human eye. So they're just showing you what the 500 objects could look like if it was sending that to the sensors. So people like Elon can use this to test their systems instead of driving them in environments. So that's a bit of Car2X, infrastructure to X. I talked about 5 and 6G, which is an interesting kind of thing. So we've got a battery drain tool here, which is looking at my favorite tool, which I just ran in my background speed test, which they got 300 meg upload here, which is quite impressive. But you can see the spectral analyzer, which is going to start pulling up the large data flow that's going through, and then waveform analysis there, which is showing you the actual protocol request responses and how you can actually inject into that maybe packet loss, kind of jitter. So we're actually controlling, which is in essence just a mobile device, but it could be anything. It could be a headset, it could be a car infotainment system. And the other thing, which again is, I say slightly interesting, but there's only a certain level of interesting when you get into this level. But, what you've got on this system, which also doesn't look like it's playing, but it could be me. It's playing, just not very exciting. Let me put it forwards a bit. What you're actually seeing is the actual the towers, cell towers, and actually all the sockets and what's been made. And then as every single call that I ever make on the train down here on Teams fails, you can actually see why what dropped to actually cause that call to hang, or you can purposely add in and inject bad messages or bad network signals to cause that device to actually stop working. So again, it gives you a bit of an idea of how you can do that at a network level. And then we kind of add into it what I refer to as network function virtualization, but or lifecycle virtualization. But what that in essence is we're doing A/B testing of a device. One device is connected to a 5G connection, one's connected to a Wi-Fi. Surprise, surprise, the battery drain on the 4G one is more. There's certain speed decreases as the data's coming through, but we can emulate this and simulate and run these kind of incredibly complex systems, obviously slightly speeded up for entertainment value, and then do the full analysis of, well, it dropped frames, the battery drain was at 20%, 30% more, et cetera, et cetera. So we can add all those kind of components in there to make it more realistic to proper life world environments like here, which I can't make a 4G connection. Now I added in robots because, well, why not? And also Elon mentioned that you'll be able to get one of these, maybe not that one, for $20,000, probably only available in Santa Clara. But what you see from here is very similar to what you saw on the headset in the sense of the additional feeds that are coming through, the three-dimensional rendering of the area. Of course, this 20,000 robot can do one thing, which is water plants. But, if we thought about putting testers into a manual world, this is one of our 6-directional robotic arm systems that we use. We can do exactly the same thing. We can literally get it to pick the headset up within one of those environmental chambers and actually move the device around, move the headset around, point it in certain directions and repeat that process, for 24/7 from factory kind of models to kind of testing environments as well. And to give you an idea what the testing environment looks like, here's a simple example with a digital twin. I say simple example, don't know why my watch is exploding. But what we're doing here, which you may be able to see, it starts a transaction off here. It then uses the robotic arm to do the chip and ping. It's obviously going through, waiting for the confirmation. It's going to remove the card in a second. What you're going to see is the EPOS system taking that transaction. And then once that transaction's gone off on the back end and it's taken the payment, which is payment successful to Stripe or whoever your payment gateway is, prints off and then reads the actual QR code and the OCR of the actual paper and checks that it's right. So you're using a digital twin to deal with interacting with the real world as well as kind of interacting with physical things. And we do this for things like payments at pump and loads of other great things. So anyway, so this is a kind of an example of how you can use a digital twin to test both software, and obviously there's 6 different systems there, and hardware. And then the exciting last few slides. So what we're doing now, what we're trying to build at the moment, which is maybe a little bit of what Adam's going to talk about as well, is applying things like our autonomous design automation to create those digital twins of the model, which I showed you, taking those and then adding what we refer to as automated test assurance, ATA, which is this ability to actually understand quality, which if thankfully if Paul was there next door, he'd turn around to me and say, there's no such thing as qualities, but thankfully he's next door, so he's not going to shout at me. But what the idea is, and this comes from kind of Satish, who's our CEO, is hardware, you have a CE standard saying, this will not explode on the plane unless it's a Samsung Node, then you can just kind of throw it. But for software, there's no understanding of the overall quality. So if you buy a SaaS solution, it might be fantastic now, but like what poor Adam's, who I've realized that he's just like been all the center of all my conversations today, Adam has to understand and deal with, governments and military systems. Therefore, you've got to be at a certain level. You've got to have a certain kind of capability around your processes, around your internal security and audits, and making sure that you're kind of going through your OWASP stuff, or you're doing your SOC 2 certifications. So each one of those is a kind of let's understand where we are, where we'd like to be, and this may be another Black Friday kind of. Should you be slightly better already, not thinking about it just when Black Friday starts, but, what's the overall experience of your product, your platform, your app? And if you think about the Metaverse and Apple glasses and Google glasses V2, every app on the App Store is just going to get moved into this mixed reality environment. What's that experience going to be like? Is it going to just be the Minority Report with loads of ads everywhere you walk, or is it going to be helping you, guide you through the app, your physical environment, giving you information about meetings, work items, etc., etc. So anyway, that's what we're trying to understand, trying to slightly understand how we take all of this data and actually learn from it, from coverage, trying to give you a bit of understanding of where within the application needs to be focused. It could be manual. You could run manual tests and augment them with automated tests and vice versa. So predictive analytics. And then I wanted to add in just kind of what we're trying to build, which I think Adam's already built. But, what we're trying to do is create a test database, which is what we call an echo database, which gives combines things like time series data with our multidimensional data, knowledge graphs, a bit like Azure Databricks, but large sets of data from lots of different exhaust systems. So if you've got Jura, you've got Selenium, you've got your security tools, all that information comes out, and then we can apply on top of that visualization and observability and things like Azure Quantum, which just needed to be added in for fun at the end. I added these on the fly, I say flight in, but the train in at 5 a.m. this morning. So I had a call with this gentleman, Dorian, yesterday when I was driving back from our Cambridge R&D labs. And he's created a free tool called Headlight Lamp Test, which is quite nifty. It actually creates, on whatever web page you've got, it highlights every single part on the application, which bits you've been to and which bits you haven't been to. And people like Mr. Whitaker and James have said, oh, this is awesome. It's a really good tool for understanding and doing exploratory testing, so I wanted to add that one in. I've taken on a new Padawan learner, Lady Low Code, who actually does testing of low code systems, so things like Appium and other low code providers like things. So should be some interesting stuff coming down the line with her. And then that's it. I do have a slide of what Eggplant does, which I'm sure I can just leave on the background while I take any kind of Q&A with the remaining few minutes. And give away some free eggs.
Of automation,
No, you don't want.
businesses all
As
over
nice
the
as
world
Eaton is.
Keysight's Eggplant solution to test all technologies.
We've got some eggies here by my wonderful assistant. So yeah, if you can ask a question, we'll give you an eggie, these are literally limited edition. If you throw them on eBay, I'll buy them off you after that. So, did you have a question?
I do, yeah.
You just wanted
I had a
fluffy
question.
toy?
Well, what I didn't see was a definition of a digital twin. I'm all about the definitions, right?
Yeah.
I've got one on the screen which has come out of industry. I just wanted to ask if you agree with it.
So that should be the same one that's in the book. So I did a definition on the book, which Rex kind of had a go at me saying, you're talking about either a physical system. So digital twins are well known in the industry definition as replicating a physical system.
Mm-hmm.
However, they're not really associated with software systems. So that definition, which is the industry definition, just needs to has been deviated to add in software systems.
Yeah, this one's actually digital. It's fit for purpose,
Yeah.
digital representation of something outside its own context, with data connections that enable convergence between the physical and virtual states at an appropriate rate of synchronization.
Yeah, which is a good definition. Apart from, this is where we got into a bit of an argument with Dr. Poppy Crump, the neuroscientist. So we were trying to talk about what's the difference between an emulator and a simulator, right? And we kind of got to the point that an emulator, in essence, is a digital twin of how this works, right? So it's a microphone, there's some kind of wave, it's got some kind of frequencies defined and limited by the actual components that exist on this device. However, if I create a simulation of a digital twin, I could then optimize that to see how I reduce battery, add different components with better threshold to then observe the behaviors and learn from it. And that's the feedback from the digital twin, is that actually I kind of use it as the, Houston, we have a problem kind of thing, is you can't connect to the shuttle, therefore you create a digital twin of it, you try all permutations, you find a solution. And that might be some sticky tape, but it might be, changing the component. But the definition which we put in the book literally makes it really simple. It's a replication of a physical or software or virtual system, which takes logic feeds over the top that makes it understand, a bit like Bruce Willis. It's not just put Bruce Willis's hat on, you've got to say EPIA and some of the sayings that he says from a cognitive perspective. So you've got to kind of model it to another level of the degree, which is kind of hopefully what that means.
What's the number one limitation that you found with basically doing sort of things like the glasses and other things that, especially in that closed space where you're in aircraft?
Yeah.
You're recording other people, sort of what are the rules and regs, and sort of what are you sort of facing as your biggest sort of bugbear, would you say?
Yeah, so that's the really interesting thing. So, when everyone talked about drones, we were doing some Hitachi, you remember Hitachi Fusion, we were doing the nuclear power stations out in Cheltenham, and they were saying, well, actually, what do we want to implement? Drones, because we don't want to put people where drones could go in and interact with the system, right? Everything should just be remotely administrated. And so all my guys started getting drone licenses, and the same thing, you had to fly, not looking into private land and all this other stuff. It was quite complicated. This is 1,000 times worse. So the reason why I'm getting, dragged back into the office this afternoon is because this is ITAR regulated, as far as they've sold for 20 billion to the DoD, these devices. So the device is a ITAR device, which means it needs to be in a lab, a bit like GCHQ. No software can enter it, no pens, no paper, no anything. Someone typically will just put the headset on, and then of course they deployed 5,000 into combat environments about 6 weeks ago, which is why I'm getting all the hassle. And everyone started getting motion sickness, because actually testing it on one person with one body structure running at a certain pace, the proton to latency response is supposed to be less than 20 milliseconds. You can't observe that as a human because you can't see 20 milliseconds. So therefore, without using a tool, there's no way to understand that by improving this, you're going to get that to be sub 20 milliseconds, therefore not people just turning up and throwing up in bins afterwards. So because the use cases, unfortunately, are military and medical ones, there's a lot more regulation around how you can actually test these systems because they're a national security asset.
Just things like prescription. It's a case, I'm with a lot.
Yeah.
I've got a unique prescription, and how's that then sort of, and there's loads of.
And that's why the new one, especially the Pro, part of it is it looks at your, when it's looking at your eye, it's actually trying to understand, if you're wearing contacts, you can change the contacts. It comes with all the different contacts in each layer. Mm-hmm. And as you optimize it, it tries to understand whether or not you're looking, and wherever you're looking, it's just rendering there, because obviously the battery would be too much to render 120 frames per second, 4K per eye. It just focuses on where you're looking at, and then it makes it visible for your eyesight, and then overlays it into the real world, which is quite interesting. I'm going to give you one of the.
I was going to say, just follow.
I'll throw it at one of our guys who can then throw it at back at you. Otherwise, HR will just annihilate me. Did you?
I did have a question, yes.
Go on, fire away.
Okay, so on a standard kind of BDD approach for testing, if there's an unexpected outcome, like traditionally, like things will just fall apart, right? So if you've got a massive BDD batch and something unexpected, like massive weight, just falls over, how do you kind of mitigate that in your digital twin approach when you see unexpected things like something is not as responsive? Does it have mitigation there? Does it throw out special exceptions?
No, is the answer to that. So because we're typically using computer vision for everything, it's either there or it's not there. If it's not found, and this is why one of the problems when we inject things like network latency or so it can't see something, it doesn't render on the screen, we just fail it. And we take an image of all of those camera feeds, those sensor feeds, and then we say, this is what happens. So they can kind of reproduce that. But it's unlike BDD, we've not got any real behaviors in there, i.e. when we start thinking about things like twilight, can we see at twilight, those ones aren't really defined, they're kind of on a per basis, which again, the acceptance criteria is really quite strict around that. So yeah, it's really quite difficult.
In your in your example of the chip and pin, watching it, it's like goes across the screen. Is it reading what it says on the screen?
So for the chip and pin system, it is using computer vision. So there's a computer vision on the top, which then looks at that's a 5, and then realizes, which is why it looks so slow, is because it's going through and pressing it and then moving and then pressing it. However, that's not actually our robotic arm. That's in a company called IntelliQA, which are really smart at specializing in chip and pin stuff. So they've actually optimized it to do that. But when we come to doing things like pay at pump, it is actually looking at it, and it's also looking at the filling value that's coming up, any kind of digital displays in that environment, and it's actually interacting with that based on going press 5, press 8, based on some driver file you put in.
So you could use that sort of technology for looking at a monitor with other information on it.
So yeah, so someone asked me the other day, which I know I'm on my last question, but someone asked me, can you help fire this nuclear submarine thing? And I said, yeah, of course. And they said, well, it's just got these 3 screens. We can't tell you what they look like. We can't tell you what the button lays out, but can you do it? And we went, yeah. But in essence, it would be able to say, press green button, like Homer could do if he wanted to, right? My last question, the guy with the red shirt, because he's wearing red, so...
When you're building your model from all the data you pulled out of all the different systems, how are you deciding what to assert when you got to a certain state? Or was it just if we get into the end of the transaction, so everything had to be the same all the way through?
So, I recommend having a look at a new startup company. It's the guy who wrote SoapUI, actually, called Test Trace, or Trace Test, otherway.io. And what they do is they take open telemetry data, i.e. an interaction like an assertion on what you get on a Postman script. But if you've got a Postman script, you've got some JavaScript, which you write in some custom code to say value must be over a certain whatever. What they're doing is taking rules that they've created associated with open telemetry to a Swagger spec or an open API 3.1 spec where it says should, could, would, whatever, and then says if there's a request that comes back with a 200 response, and it contains a approved, then straight away it actually creates an assertion with a template that says look for approved. Now, of course, you might find that actually that's no use. You're gonna have to build it out, and that's where suddenly you start having to look at service virtualization and mocks and stubs and building more realistic models for those. But it will discover those ones and create another one, and that's a free tool you can download. The guys are really nice. Anyway, I will.
Thanks, Jonathan, for that great talk. I think Jonathan will be here all day.